Hello and welcome, everyone. My name is Dane Menke. I am the Digital Marketing Manager here at REGENESIS in Land Science. Before we get started, I have just a few administrative items to cover. Since we're trying to keep this under an hour, today's presentation will be conducted with the audience audio settings on mute. This will minimize unwanted background noise from the large number of participants joining us today. If the webinar or audio quality degrades, please try refreshing your browser. If that does not fix the issue, please disconnect and repeat the original login steps to rejoin the webcast. If you have a question, we encourage you to ask it using the question feature located on the webinar panel. We'll collect your questions and do our best to answer them at the end of the presentation. If we don't address your question within the time permitting, we'll make an effort to follow up with you after the webinar. We are recording this webinar, and a link to the recording will be emailed to you once it is available. In order to continue to sponsor events that are of value and worthy of your time, we will be sending out a brief survey following the webinar to get your feedback. Today's presentation will discuss innovative remediation via PetroFix injections and flooding active tank basins. With that, I'd like to introduce our presenters for today. We are pleased to have with us Monica Young, Senior Project Manager at CGRS. Monica Young has over 24 years of environmental experience and specializes in site investigation and remedial activities related to petroleum hydrocarbons. She's been with CGRS for 20 years. Prior to that, she worked for the U.S. Environmental Protection Agency Region 8 out of Denver, Colorado, in the underground storage tank and leaking underground storage tank program. She is a recognized environmental professional with the Colorado Division of Oil and Public Safety. We're also pleased to have with us today Todd Herrington, Global PetroFix Product Manager for REGENESIS. Todd directs the expansion of the hydrocarbon treatment line in the global marketplace and provides industry-leading support to REGENESIS customers. He has over 25 years of environmental remediation experience, primarily focused on in-situ remediation. He has been involved with thousands of contaminated site remediation projects during his tenure at REGENESIS and has expertise with enhanced bioremediation, chemical oxidation, chemical reduction, and carbon sorption. All right, that concludes our introduction. So now I will hand things over to Monica Young to get us started.
Thank you very much, Dane. Thank you all for attending this webinar. I am excited to share two of CGRS's sites with you, wherein we use PetroFix to remediate petroleum hydrocarbons. The first site I'll be sharing with you is located in the Denver metro area of Colorado. At this site, we perform traditional direct push PetroFix injections. In fact, REGENESIS prepared a case study on this site in 2021, which you may have seen. The benzene concentrations were reduced by 99%, and since then the site has received no further action determination by meeting the Tier 4 risk-based closure criteria. This site was a retail gas station that operated between 1976 and 1992. They had two 8,000-gallon steel underground storage tanks that did not have corrosion protection. This led to extensive corrosion that was observed when the tanks were removed in circa 1992. The dissolve phase plume extended south under a city street and an off-site commercial property. This top photograph shows a site in circa 2000. And here is the off-site commercial property that is south of this here source property. Between 2004 and 2017, CGRS performed various remedial strategies. In 2004, soil vapor extraction was performed at the on-site source property and had to be removed after 1 year of operation due to upcoming development of the property. The system removed approximately 1,500 pounds of hydrocarbons. While the on-site property was under construction for the new development, CGRS performed limited excavation and removed approximately 850 cubic yards of petroleum-impacted soil. Additionally, CGRS worked with the redevelopment general contractor and installed a soil vapor extraction and oxygen diffusion system on the source property and off-site in conjunction with the construction of the new building. Again, this top photo shows the on-site source property. Here it is with the new commercial building. And this figure shows the commercial building. Here's our remediation shed and our piping and remediation system that surrounds the south portion of the property. We horizontal bored under the city street here and expanded the system to the off-site commercial property. The system operated for approximately 8 years between 2007 and 2015. The SVE system removed approximately 5,500 pounds of hydrocarbons. The system was turned off due to asymptotic conditions. BTEX concentrations in groundwater were reduced but still above the Tier 1 risk-based screening levels. In 2013, CGRS performed a carbon-based injection event, which included 31 points over the majority of the plume. After the injection event, the benzene concentrations in groundwater remained above the Tier 1 RBSL. In 2017, CGRS partnered with REGENESIS Remediation Services and performed an in-situ chemical oxidation injection event, which included prosulfox, REGENOX, and ORCA as the injectates. There were 74 injection points in 5 areas. After the injection event, the BTEX concentrations were reduced but still above the Tier 1 risk-based screening levels. Again, this figure shows the bottom portion of the on-site source property with the injection points in Area 1. Here's the off-site commercial property with areas 2, 3, 4, and 5. The above-mentioned technologies decreased the contaminant mass in soil and groundwater, but was not enough to request no further action. The extent and magnitude of the benzene plume in groundwater remained above the Tier 1 risk-based screening level, with concentrations ranging between approximately 5 and 21,000 micrograms per liter. The treatment area was approximately 6,000 square feet, and the majority of the treatment area was the off-site property, as you can see in this figure here. Again, the on-site source property. Here's the city street, and the benzene plume, the majority of it is on this off-site commercial property. Before a possible second ISCO injection event could be performed, PetroFix was released by REGENESIS. That's when CGRS decided to inject PetroFix. And again, the on-site source property, here's our injection points for PetroFix in the city right away, and then all the different injection points for the PetroFix on the off-site property. In August 2019, CGRS partnered with a local drilling company to pothole 111 points and backfill with hydrated bentonite. You can see that in this photograph here where the wooden stakes are. That's all the injection point locations that were potholed and backfilled with the hydrated bentonite. In September 2019, CGRS partnered with REGENESIS Remediation Services, who was supported by the same local drilling company to perform the PetroFix injections. Approximately 29,600 pounds of PetroFix and 1,480 pounds of electron acceptor blend were mixed with water. Approximately 20,000 gallons of the mixture were injected into the 111 points. The injections were performed in 3-foot intervals in varying depths. For our PetroFix barrier at the source area property, the injection interval ranged from 6 to 13.5 feet below ground surface. At the off-site property, our injection interval ranged from 12.5 to 25 feet. In this photo, this is a local drilling company, and they supplied the direct push rig and personnel, and they use REGENESIS tooling, rods, equipment to perform the injections with REGENESIS. Average pressures were approximately 19 psi with a flow rate between 2 and 3.5 gallons per minute. Design verification is key to the remedial success. In the smear zone, the soil was clay to sandy clay. In the saturated zone, the soil consisted of clay to sand to gravelly sand. Average depth to groundwater offsite was approximately 15.5 feet. To ensure that the PetroFix was being distributed well into subsurface, we obtained soil cores, and you can see the black PetroFix in the photograph in the sandier soils, as indicated here. The field crews made real-time adjustments to make sure that the PetroFix was being injected into the sandier flux zones versus the resistant clay zone. Also, we observed PetroFix in the groundwater monitoring wells. We sampled these wells with passive diffusion bags because the colloidal carbon in PetroFix will not infiltrate the passive diffusion bags. The benzene concentrations decreased sharply by the first monitoring event, which was 3 months post-injection, and were maintained through subsequent monitoring events. This slide shows the benzene plume pre-injection on the left. Post-injection, the BTEX concentrations in groundwater were below the Tier 1 risk-based screening levels. After 11 months post-injection, we started to see a slight rebound in benzene concentrations in the figure on the right. This is monitoring well MW19 at the edge of the property. We were not able to inject in the city sidewalk due to the subsurface utilities in the area. This is well SVE5 and was outside of the PetroFix treatment area. This well would have intermittent benzene concentrations that exceeded the Tier 1 risk-based screening level. Overall, you can see the dramatic decrease in the benzene plume after injections. Here is the BTEX performance in groundwater showing the dramatic decrease post-injection. Even though the benzene concentration in groundwater from monitoring well MW19 rebounded slightly after 11 months, it was still an order of magnitude less than pre-injection concentrations. As mentioned above, we believe this occurred because well MW19 was on the edge of the property. In hindsight, we should have increased the volume of PetroFix in the injection points near well MW19. This graph shows the same performance for the TPH concentrations in groundwater. In summary, the PetroFix reduced the benzene and TPH mass to below lab reporting limits in most cases, or at least 99% reduction. The reduction was maintained continuously for approximately 18 months post-injection. On August 6, 2021, the Colorado Division of Oil and Public Safety issued no further action for this release due to meeting the Tier 4 risk-based closure criteria. Redevelopment of the off-site property is underway, as you can see in this photograph. Tips for success. It is imperative that the PetroFix is injected into the flux zones so that you can achieve the distribution needed to remediate the contaminants. The best way to confirm this is with pre and post injection soil cores so that you can see the distribution of your PetroFix in the sandier flux zones and adjust accordingly, as you can see in this photograph here. The PetroFix injections need to be performed with low pressures and flow, with bottom-up sliding multi-port tooling. If impacts are near the edge of the property and you are unable to inject all around that area, you should consider increasing the volume of the PetroFix in the injection points near the property boundary. For this project, I worked directly with Todd and his team to design this injection event due to the size of the benzene plume and amount of injection points. It was a great collaboration between CGRS, REGENESIS, and their remediation services team for the application, and our local drilling company. The next site I will be sharing with you is also located in the Denver metro area of Colorado. At this site, we flooded the tank basin with PetroFix and it had successful results. In 2021, REGENESIS prepared a summary case study on this site, which you may have also seen. At this site, we injected into the active underground storage tank basin via shallow injection wells. The goal was to reduce the BTEX concentrations in groundwater in the tank basin. Due to the active gas station infrastructure and lithology, direct push injections could not be performed. In May 2017, a suspected release was reported to the Colorado Division of Oil and Public Safety, OPS, due to stained soils discovered during the replacement of the UST spill buckets. 4 groundwater monitoring wells were installed around the tank basin. Benzene, ethylbenzene, and xylene's concentrations in groundwater exceeded the Tier 1 risk-based screening levels. OPS tasked CGRS to remediate the dissolved phase BTEX concentrations in the tank basin. Traditional injections could not be performed due to the shallow bedrock, dense UST infrastructure, and subsurface utilities in the area. The maximum BTEX concentration was 6,553 micrograms per liter in the tank basin prior to the PetroFix injections. There are 3 10,000-gallon and 1 12,000-gallon fiberglass reinforced plastic tanks and fiberglass reinforced plastic product piping. The dissolved phase plume encompasses the tank basin, as you can see in this figure. The native soils are clay sand overlying the weathered bedrock. 12 injection wells were manually installed around the tank basin to a depth of approximately 4 feet. The trickiest part was determining where to install the injection wells so that we didn't hit the tanks, product piping, and subsurface utilities. The injection wells are the IW wells in this graphic. The WMW wells are our monitoring wells. The injection wells were comprised of 2 feet of screen and 1 foot of riser. The injection interval was approximately 2 to 4 feet below ground surface. The UST basin effective pore volume was calculated at approximately 31,000 gallons. It was recommended that we inject approximately 16,000 gallons to reach approximately 50% effective pore volume filled. CGRS partnered with a local injection company to perform the PetroFix injections. In July 2020, a pilot test was conducted with 400 pounds of PetroFix, 20 pounds of electron acceptor blend, and roughly 4,100 gallons of water. We performed a pilot test to make sure that we would have full distribution of the PetroFix in the tank basin prior to performing the full-scale event, and the pilot test was very successful. In September 2020, the full-scale application was performed with 4,400 pounds of PetroFix, 220 pounds of electron acceptor blend, and approximately 4,300 gallons of water. The mass of PetroFix remained the same, but the volume of mixed water was limited to prevent the tanks from possibly floating. Even with less volume, the distribution was excellent. The treatment area was approximately 3,000 square feet. PetroFix was observed in key monitoring wells around the tank basin after injecting approximately 1,200 gallons, which was less than 10% effective pore volume filled. Approximately 8,400 gallons of PetroFix was applied during the pilot and full-scale events and achieved full distribution throughout the tank basin. This was less than 30% effective pore volume filled. This included a total of 4,800 pounds of PetroFix and 240 pounds of electron acceptor blend. The average pressure was 3 psi and the average flow rate was 2 gallons per minute per injection well. The depth to water in the monitoring wells did not rise more than 2.5 feet. In this photo, the top photo, you can see we're connected to the various injection wells around the tank basin and we're applying the PetroFix injection. And here's the injection trailer. The PetroFix injections were performed in 12 injection wells that were screened approximately 2 to 4 feet below ground surface. This allowed the PetroFix to safely percolate downward into the tank basin. The average pressure was 3 psi per injection well, which did not disrupt the active UST system. We experienced minor daylighting of the injectate due to one injection well could not be placed in the tank basin due to the UST infrastructure and subsurface utilities in the area. So that well had to be placed on just outside of the tank basin in the native soil. Low flow samples were taken at approximately 1 foot below depth to water and approximately 1 foot above the bottom of the monitoring wells in the tank basin, which showed near immediate and full vertical distribution of the PetroFix. As you can see in this photo, this is the 50 milligram per liter standard of PetroFix, and these are water samples from various wells, and you can see the higher concentration of PetroFix in them. Here is the March 2020 BTEX and TVPH concentrations in groundwater prior to the PetroFix pilot test injection event. The concentrations in red exceed the Tier 1 risk-based screening levels. As you can see, we have a lot of exceedances. Here are the March 2021 BTEX and TVPH concentrations 6 months after the full-scale PetroFix injections. All the BTEX concentrations are below the Tier 1 RBSLs. In fact, the majority of the concentrations are below the lab's reporting limits. Since we observe PetroFix in the wells that are in the tank basin, we use passive diffusion bags to obtain our groundwater samples, just like how we did in the direct push injection event for that site I previously discussed. And again, the PetroFix colloidal carbon will not infiltrate the bags. Here are the March 2022 BTEX and TVPH concentrations 18 months after the full-scale PetroFix injections. All the BTEX concentrations still remain below the Tier 1 RBSLs, and again, the majority of the concentrations are still below the lab's reporting limits. In summary, the PetroFix reduced the BTEX concentrations by almost 100%. We achieved almost 100% reduction of the TVPH concentrations. The objective to remediate the tank basin is being achieved. CGRS anticipates that the BTEX concentrations in groundwater will remain below the Tier 1 RBSLs for the next 2 quarters. Then we will have 6 quarters with no BTEX concentrations rebounding above the Tier 1 risk-based screening levels. Thereafter, CGRS will request no further action. Tips for success. The tank basin must be backfilled with a coarse-grained material such as pea gravel for the tank basin to flood. And install the shallow injection wells. Take your time to determine the location of these wells, keeping in mind the edges of your tanks, product piping, electrical conduits, and subsurface utilities. Usually, there are no as-builts for UST systems. You should open the STP sump lids and try and determine which way the product piping may be running to the dispensers. It took 2 of our field techs and myself approximately 3 hours to determine where to install the 12 injection wells around the tank basin at this site. Monitor your rise in depth to water. If the rise in depth to water is getting near the tops of the tanks, consider decreasing the amount of mixed water. Main objective is to get the mass of PetroFix injected. Todd always told me that we need to get the mass of PetroFix in the subsurface, whether it is by direct push or our injection wells. We can always adjust the amount of mixed water. Obtain water samples from your monitoring wells around the tank basin to confirm that you are achieving the vertical distribution of PetroFix in the tank basin. Your shallow injection wells are now part of the infrastructure, so they can be reused if additional applications of PetroFix are necessary. For this innovative project, I worked directly with Todd and his team. CGRS shared with them where we wanted to install the injection wells, and REGENESIS determined the PetroFix injection design. It was a great collaboration between CGRS, REGENESIS, and the local injection company. Thank you. I'll turn it over to Todd now.
All right, Monica, thanks. Thanks for that. I know I was involved with those case studies, but it's so helpful to actually hear you give that and some of your lessons learned and stuff. It's just helpful details for me to think about, hopefully for our viewers to think about as well. So rounding out the second half of this webinar, I want to give a little bit of an introduction and overview of PetroFix and approaches to audience members who may not be that familiar with PetroFix, where it might be a little bit new to you. And then we'll get into Q&A on that. So I'll probably go maybe around 15 minutes or so, and then we'll get into Q&A. So REGENESIS has been around since 1994. It's 28 years in business. And one thing that's unique about what we do is we actually research and develop our own technologies, and each is really finely tuned for its specific purpose. We also have a network of just fantastic district managers and tech support personnel around the world to do cradle to grave support. And we've been able to do that on over 26,000 applications using this extensive portfolio of products that we have. I think it's probably, by my count, upwards of around 20 chemistries that we can use. And but we were asking the question back in 2007, give Scott Wilson, our CEO, credit, that just asking the question, can we do better? Is there a way that we could access an aquifer? Aquifer's porosity was something that would give us more speed and certainty for solvents, et cetera. And that's when the research for intercolloidal technologies began. 7 years later, we went full commercial release with a technology called Plume Stop, which is our flagship colloidal activated carbon technology. We settled on a carbon-based technology, and that has been doing tremendously well as we treat solvent plumes, various VOC plumes, PFAS across the world. But we saw a need with this technology as we got into some hydrocarbon sites. We couldn't always do every hydrocarbon site we wanted. And so we developed developed a product called PetroFix and launched this in 2018. That's what we're talking about today. That was specifically designed with certain features for hydrocarbon sites. And as I'll get into a little bit later, something unique where we are going to allow the market to self-design and self-application for this technology. And so since this launch, and I came on board as a PetroFix Product Manager. I've been here for over 18 years, but I've been doing this role for about 3.5 years and a few months after PetroFix launched to help just support this expansion, support our customers, write them the training materials that we need, assist in many different ways. And I've been able to oversee its use, or I would say participate in its use on 560 sites worldwide. I'm just completely thankful that this has been so successful. 42 states and 15 countries. Very thankful for customers like Monica that have been with us from the very beginning as we grow. So just very excited for this hydrocarbon treatment technology and kind of for the next phase moving forward. I'm going to give an abbreviated overview compared to what we've done in the past, but more of an abbreviated overview of PetroFix and exactly what is it? How does it work? As I said, it was an evolution of our plume stop technology. It uses the same colloidal activated carbon as plume stop, but it's been modified. We have a higher density of carbon that we use, but we also blend or add electron acceptors to it. It also doesn't have the same dispersant polymer chemistry that plume stop does, so it doesn't quite go as far as our plume stop technology. But aside from that, very, very adept at treating hydrocarbon sites. So we're dealing, when shipped to site, with a fluid that has a viscosity near, kind of like a motor oil. You can see a gentleman here stirring a PetroFix drum with this fluid on the upper right. It has over 30% by weight of suspended carbon, which makes it so thick. That is diluted and filled, and then the PetroFix is shipped with electron acceptors as part of the design, as part of the product. It comes in 20-pound buckets. The white powder is our nitrate and sulfate salts that are water soluble, and they co-migrate with the PetroFix, which is a big advantage. And so certainly they come in containers that people are familiar with, can easily move around on site. So let's talk about the attachment, and I just would like to frame these next couple slides as think of PetroFix as injecting a liquid. I know it's a colloid, so technically we're injecting a solid, and we're not injecting a solution per se. But because it's been milled down to the size of a red blood cell, which is 1 to 2 micrometers, and suspended, it handles like a liquid. It's very easy to handle. And so when we inject it, this animation is showing sort of a zoom in, and these black particles are the PetroFix, 1 to 2 micrometers, and they are going to flood into an aquifer. And as they flood in, they will start to immediately attach to the surface of the soil. And as the distribution agents that we have start to subside, and over time, the PetroFix completely attaches to the aquifer subsurface. And that usually, I could say, takes days to weeks. I would say sometimes more like weeks to months. I would say in Monica's case, because we had actually dosed so heavily, it took a bit longer, which is one of the reasons that she used passive diffusion bags. We can maybe get into that more later. But once attached, the exciting thing is that PetroFix is fully positionally stable, which means it doesn't continue to migrate like this big cloud of dissolved ink. It stays in place, and the groundwater clarifies, and that's how you sort of, we like to say at REGENESIS, turn your aquifer into a filter. I've shown this image probably almost every presentation I've ever done. This is a scanning electron microscope image zoomed in on a sand particle. And we use this to show what happens when we add our colloidal technologies. And what happens is that, like I said, it coats things. And this roughness on the sand particle is not the natural roughness of sand. It's actually the colloidal activated carbon that's on it. And so notice all the space in between, all the space in between the sand particles, the openings or the porosity. We're not clogging things up. There's plenty of room for groundwater to migrate through and for contaminants to be absorbed out. So what next? So the next thing is that we do actually biodegrade contaminants. We stimulate that. And PetroFix does include ammonium sulfate and sodium nitrate as the major electron acceptors, and those almost immediately start to stimulate bacteria. Most aquifers that have been there for some time are completely depressed and have run out of electron acceptors, and the kinetics are very, very slow. Adding these, and they build up very, very quickly, well, without the addition or need for additional bacteria. So once we kickstart those bacteria, we do get growth on the soil. That bacteria does grow around and incorporate many times the petrofix and the biomass, and you start to get the biodegradation of contaminants. And the way that works is contaminants adsorb. They're biodegraded off of the petrofix, which frees up additional sorption sites. And if you free up additional sorption sites, the term for that is we're regenerating the carbon, which extends the longevity, which really is what helps make this technology so powerful. And the other thing that's great about the fact that we're doing surface coatings on the soil is that when we put this amount of activated carbon into the subsurface, we get an almost immediate and total removal of hydrocarbons from the dissolved phase very quickly. And what that does is the aquifer wants to re-equilibrate. And that re-equilibration happens when you have contaminants, say, in low K units, or like we like to say clay, starts to move into the higher K units, the flux zones, or a process known as back diffusion. PetroFix is excellent for treating this phenomenon, for treating these persistent low-level contaminant concentrations we have because of back diffusion. I had an interesting question the other day. I thought I'd bring it up, and I'm going to switch into about why PetroFix is formulated the way it is and what the impact of having stable colloidal carbon is, and get into some ideas on applications. We ship this in water because we can't do it any other way. When we manufacture and get the milled PetroFix down to 1 to 2 micrometers, if we don't manipulate it, it just clumps together and settles out, and it's just no good. So the transport polymers have to be added in the aqueous phase, or it just doesn't work. We can't sort of take a dry polymer, dry carbon, mix it together like you're mixing, instant coffee, and there you go. The other thing is safety, that even if we could ship this, we really wouldn't want to. When you're dealing with something that small, it can be probably a pretty significant fugitive dust issue or health and safety issue. So keeping it in a water medium makes all the sense in the world. And ultimately, we were going for something that we could access the entire pore space of an aquifer more easily and with more certainty and persistence. And really, so we end up with a stable colloidal activated carbon injectate. And that's where the magic is happening. And what's the impact of that? What's the impact of having something stable that you can keep on site? You can store, take it out, and dilute it and inject it. Well, as Monica showed on her one site here in Colorado, the injection in the tank basin flood, having a stable colloidal activated product makes it easy to get pretty good distribution in critical flux zones, as she showed on her injection site. One thing that I want to point out is that the size of the PetroFix is actually so small that it will actually go through the typical range of pore throat size for silt, which is 3 to 8 micrometers in diameter with low pressure. It can go into it. It can even diffuse into silt. So that's a great thing. We can access more aquifer. using the image on the left, on the lower left, this is not actually that dissimilar from the site that Monica was talking about. She had interlayered clay with more sandy zones. PetroFix is a groundwater treatment technology primarily. Because we're adding electron acceptors, yes, there's some soil treatment that happens, but by and large, we're not going to get rid of high levels of soil mass. What we're trying to do is we're trying to lock down and immediately treat over a long time plumes of a great range of concentrations. So we're targeting flux zones. That's what it's designed to do. We're not injecting PetroFix in clay, but how many clay sites do you know? I mean, let's just put it this way. Groundwater contaminants plumes don't migrate through clay, but they migrate, I should say, contamination migrates through sandy zones that are interlayered or surrounding clay zones. So we're not trying to target clays, but we're targeting those zones where we can place high loads of our PetroFix exactly where we need, so that we wall to wall, ceiling to ceiling are covering those flux zones, very similar to the pictures that Monica showed, which gives you a high certainty of distribution. It gives you a high certainty of treatment and great longevity that way. Whether it's a sandy clay, silty sand, that's primarily how it works, and that's really what we're going for. I guess I forgot to mention, I had this animation going earlier. That's mixing a PetroFix. That's Ryan Hardenberg on the left. That's me on the right, and mixing the electron acceptors. Once it comes together, just a couple minutes of mixing, you're able to put it in. All right. Another benefit of having a stable liquid is that when diluted, it's safer around infrastructure, and it gives you that certainty of application, in the sense that we did a lot of research on various colloids, and we did a lot of research on different forms of carbon before settling on the plume stop and PetroFix, looking at powdered activated carbons, granule activated carbons. We feel that there's some challenges with those larger products, larger in diameter. When you mix them with water, they're not a stable colloid, they're not a stable solution. They settle, or they agglomerate together and form thick slurries, which makes it harder for them to get in the ground. So typically these are high pressure fractured in the subsurface, whereas you can get pretty nice radius of influence. It's typically going through fractures that are separated by usually 2 to 3 feet apart under high pressure. You can get preferential jetting if under several hundred PSI, this material hits a corridor, a monitoring well. You can fill those up. It can cause problems that way. Frequently, you have to replace wells if that happens at a site. And with the PetroFix fluid, stable colloidal activated carbon, it flows through an aquifer similar to the way a contaminant's going to flow through an aquifer, similar to the way groundwater flows through an aquifer, migrating through the pores, in and out of a well, but not preferentially going into that. So a lot of sites were able to just flush a well when we're done. It's not a big deal. And well integrity is maintained, and there's a confidence, as you can see, floor to floor, ceiling to ceiling, wall to wall, ceiling to floor distribution. What I mean by that is Monica showed a great soil core from her site. Here's another one that we pulled from another site that just shows what even distribution looks like. And you have to ask the question, are you confident or not that this is going to stop, say, benzene from getting through? I would say if we see something like this, we're going to be pretty confident. Oh, so, okay, rounding out just the last couple slides, I just want to show, I want to transition now into taking a liquid and what are common applications and what are some emerging applications. Commonly, of course, direct push. Let's treat a plume. Also frequent, I'm going to say not as common as a grid, a direct push grid, is the use of PetroFix as a long-term barrier wall. This is being used both for plumes that have already crossed a property boundary, or preemptively to stop a plume, say heating oil spill. We've seen that where somebody wants to stop it from crossing a residential property boundary. Very legitimate application for PetroFix, and also a very common one. If you're digging soil out, we've been doing this for a number of years with ORC to backfill with ORC. Well, now we're backfilling with PetroFix to give an insurance policy if there's any missed sloughing, any missed sidewall contamination, that you're not recontaminating that excavation. So taking these concepts a little farther, so one of the things that we've noticed is because PetroFix has online software and people can order small quantities of this, they can play around with it, you know, they can experiment, quite frankly. And so a lot of what we see out there is our customers just being creative. One of the creative areas has been with in-situ spill response. And the idea is that we've seen applications where you've had a truck rollover, the initial spill response activities, where people go out there and they vac out or they excavate out the readily available volumes of fuel. But the question comes up, whatever I missed and whatever I left behind, is that a risk? And if it is a risk, what's the impact as it continues to dissolve and move towards a critical stream or receptor? Is there anything we can do? PetroFix is being used both as sort of an in-situ surface treatment within trenches, similar to an excavation application or injections to prevent the spread and risk to receptor. And these are done fairly close to that original spill response activity, like within a few days to a few weeks, versus waiting a couple years after the fact. So that's something new and we're pretty excited about. Taking the concept, the construction barrier, something we've focused on quite a bit last year is that we've had some success or just the attractiveness of being able to use direct push to quickly, with not a lot of logistics, install a subsurface groundwater barrier has appealed to our customers. And why is that? We've had some customers that have been looking at large civil level constructed barriers with a lot of equipment, as kind of shown in this diagram, which shows the construction of a slurry wall. The PetroFix gave the advantage of having less machinery, no piling mats, no excavation, no offsite disposal, you know, a program construction savings and cost savings. And you know, we had one done, quite a pretty large one done in Sweden, which kind of keyed us onto this. And finally, I would say I'm gonna give Monica credit. She didn't give herself credit, but I'm gonna give her credit that she's kind of at the forefront, and she saw the utility of taking PetroFix and flooding into a tank basin. I gotta admit that when she first called me about it, I was pretty resistant about it because I just didn't know really how to go about it. I didn't really have a system to kind of point it, so we had to pilot test and figure it out. But I think since she's done it and we've talked about it, this is actually becoming pretty frequent. We're seeing a larger and larger number of sites where this is viable. And why is that viable? One of the reasons is what she ran up against is a lot of times when we do designs, these tank basins are a problem because a lot of times people don't want a direct push around them, but we know that there's a source there that's probably a long-term source that we probably need to get rid of. And so if we can flood into that or flood into the transport lines around that, that offers real potential. And interestingly, not only sort of after the fact, but there's some practitioners are asking the question, well, what about if I do this before the spill occurs to handle chronic contamination over time? Here's some pictures of doing that. Here's a spill response we did. Actually, I have a case study for up in Montana where truck rollover and diesel spilled in a trench, 250 feet of trench were contaminated with diesel. And even after the dig out, it was still there. So putting PetroFix down, they were able to get that site closed within about a month. Here's a half-mile replacement of a construction barrier that was done in Sweden. And of course, Monica's site here. All right, this is my last slide. And I just want to let people know, you know, as far as it goes, our website is a great resource. And one of the unique things about this technology is that we've handed over many of the design tools that we use internally, externally to you in terms of a design assistant at petrofix.com. It's an opportunity for you if you're thinking, I'd like to maybe, I've got a site, I'd like to know what the cost and approach might be for an injection grid or an excavation. Those are two approaches that we can do. We're still at this date doing barrier applications offline. We'll do those for free. All the resources are there, case studies, application resources, training videos to help you go. And, you know, this is an image on the right of, you know, the output that you can get, all the costs are there. So you can submit these for your remedial action plan or your work plan. And if you got any questions, which you will, like I said, this is a full, we care and we want to make sure you're comfortable with this technology. We've just implemented live chat. That's for real, that if you're on our website and you see live chat, there's really a person there. A lot of times it's me if I'm sitting at my desk. We have 3 other engineers that are there. So I would say at least half the day we have coverage on that. So feel free to reach out and we're happy to even do a desktop share for you on that. So anyway, I think I'll wrap up there because let's get into the questions. And Dane, why don't I turn it over to you?
All right, thank you very much, Todd. Yeah, as Todd mentioned, that does conclude the formal section of our presentation. So now we'd like to shift into the question and answer portion of the webcast. Before we do this, just a couple of quick reminders. First, you will receive a follow-up email with a brief survey. We really appreciate your feedback, so please take a minute to let us know how we did. Also, after the webinar, you will receive a link to the recording as soon as it is available. All right, so let's circle back to the questions here. This is a question for Monica. And Monica, the question is, why do you think distribution with PetroFix worked as well as compared to other technologies that were tried?
Thank you, Dane. I think we were successful with the distribution of PetroFix because we made sure we were injecting into the sandier flux zones. We used 3-foot-long bottom-up sliding multi-port tooling and injected under low pressures and flow. This achieved the goal of filling the pore spaces. We had 111 injection points, so I think we had good coverage of the benzene plume.
Yeah, I want to add to that too, if I may, is that Monica she had one of the slides on distribution testing as well. And we did make some minor tweaks out there. And I think Monica believes this, and I think it's one of the things that we try to encourage our customers is to view our designs as not static but dynamic. You know, we've used our best engineering judgment to give a spacing and a volume that we think is going to give ROI overlap. And we could be off, like we could have missed it a little bit, but I think that getting real-time feedback in the field, she showed the soil cores that they took, looking for groundwater, like petrifixing groundwater. If you're not seeing that, that lets you know, hey, I might need to make a volume or pressure or spacing adjustment. We actually had to make a couple minor adjustments at her site, but I think that was helpful as well.
Correct. Yeah. And like
All right.
Todd was mentioning, you know, getting your soil cores so you can see where the flux zones are so you can make real-time adjustments in the field.
Okay, thanks, Todd. Thanks, Monica. So here's another question here. This one is a 2-part question. It's for Todd. It is, how do you deal with PetroFix in wells if you don't or can't use bags like the case study site? And then the second part of that is, when can I sample PetroFix after the injection?
That's a great couple questions. All right, yeah, I'm glad that question was asked because I kind of felt like I wanted to bring this up. Anyway, so I'll mention. So Monica mentioned the use of passive diffusion bags. Didn't say a lot as to why, but in general, at a PetroFix site, at most sites, the aquifer, that attachment period is as I've looked at these 560 sites across the US and the world, most of the time it's within the first quarter that people can inject and come back for Q1 sampling, and things have clarified to the point where they can sample. There is a point where there's enough suspension that it will interfere with the typical, say, 8260 analysis in the field, and you don't want to send it in. that's what Monica was up against. We actually had hit her site pretty hard, and it persisted longer than normal, and so she opted to use passive diffusion bags. And I don't know if anybody knows what those are, or everybody does, but they're bags that you fill with DI water. You hang them in a well, and they equilibrate with the aquifer. They don't let colloids in, but they allow the groundwater in the bag to come to equilibrate, and so you can take them out, say 2 weeks later, and get really accurate samples that way. So that allowed her, depending on well location, whatever she needed to do, to take that. I would say our recommendations are, we just uploaded a new document that you can go to our website called a Groundwater Sampling Tech Bulletin that I and several people spent a lot of time internally at REGENESIS providing. That's going to give you a lot of tips and tricks. I take a look at our resources section for that. But I would say for people who are doing that is you can do a clear water flood, a clean water flood at the end of an application. That helps just sort of push PetroFix back out of the formation so it's out there. Just good well technique, making sure your wells are clean. We've had incidents where people have done injections and they've got siltation that's already occurred in their well, and the black of the PetroFix gets into that silt, and when they drop balers and stuff in, it clouds up into the well. It gives false positives. So these are certain things that can be done. Certainly passive diffusion bags can be done. And then I would say wait. If you can wait another quarter or another month, that's typically what we recommend. And to help with that, all PetroFix jobs ship with a free field concentration test kit. So you can take that test kit and monitor PetroFix concentrations in your well and see what it is. And anything under 100 milligrams per liter is completely safe to sample. You can send it to a lab. And in fact, there's going to be a presentation on that at Battelle that's coming up by Heather Lord of Bureau Veritas Labs, who's done research on this, on the ability to sample at these concentrations, even though it appears quite dark. So I would just point people towards that tech bulletin, and there's a lot more information there. I've only shared about half of that, but I want to get to other questions.
Okay, so we have another question here for Monica. And Monica, the question is, had you considered expanding the SVE system?
You know, we did not, because the SVE system reached asymptotic conditions, and the on-site plume where the source area is was under the new commercial building, so there wasn't much room for us to expand the on-site system. And then in circa 2014, there was talk that the off-site commercial property would be redeveloped sooner than later. So it didn't really make sense to expand the system on that off-site south property and then to have all that being torn up. So we thought, okay, let's try, the treatment train. Let's try the next step. And as I mentioned in the presentation, we tried a powdered activated carbon injection event, and then we did ISCO, and then we followed up with the PetroFix injections, which did the trick.
All right, well, thank you very much, Monica and Todd. We are out of time, so that is going to be the end of our chat questions. If we did not get to your questions, someone will make an effort to follow up with you. If you would like to learn more about environmental services from CGRS, you can visit cgrs.com. If you'd like to learn more about remediation solutions from REGENESIS, please visit regenesis.com. Thanks again very much to Monica Young and Todd Herrington, and thanks to everyone who could join us. Have a great day.